कल आपको हमने बताया कि there is more to what you already know about electrons. You have been visualizing electrons as point charges, as a particles or whatever with negative charge, and because of on account of negative charge they have repulsion. So when you bring them together, there will be repulsion, energy will increase. So that's a simple pure electrostatic energy that you have been talking about. You have been knowing all along so far. But yesterday I discussed that there is a possibility of something what we call as exchange that can happen if they are in degenerate orbitals having same energy, and then if electron number 1 and electron number 2, there is possibility that they can exchange their places, and you can have a new configuration where the electron number 2 is in the px. Initially it was like suppose, so जो पहले py में इलेक्ट्रॉन था वो अब px में आ गया है, and this is we call as exchange, and per exchange there is some energy that is released, and or in other words energy is lowered due to such interactions. And this particular thing is exchange energy, we treat it as negative. Of course जहाँ भी energy decrease होगा उसको हम negative, and then we put this configuration at the lowest. So a simple P2 configuration has now three different views. You can understand it. So just सोचिए कि जो P2 configuration दो इलेक्ट्रॉन को लेके हमने सोचना शुरू किया, और अब हमारे पास उसका तीन एनर्जी का स्टेट आ गया. We are now having three energy states. One when they are having parallel spin, another when they are having unpaired but different up and down spins, but they are in different degenerate orbitals, and then the third one when they are in the same orbital. So this is what we discussed. And so Coulomb pi c is the Coulombic energy, the repulsion when you are putting in the same area around nucleus, and this is the exchange energy. Just inverting this thing gets you much lowering of energies here. When they use invert the spin, make both of them of the same spin, parallel spins. एंड यही राज था आपका कि क्यों पैरेलल स्पिन वाले एक्स्ट्रा स्टेबल होते हैं. यू विल जस्ट सी, and a little bit more you can understand on this exchange energy with ये जो formula है, this is empirically you can understand from this. The first thing is that you should be able to draw as many structures as possible for the एक कॉन्फ़िगरेशन के लिए. कितना हो सकता है, जैसे कि यहाँ जस्ट वन एक्सचेंज का एग्जांपल दिया गया था आपको. कौन सा था, कहाँ गया इसके पहले. सो here we discussed there is one exchange P2. Now let's think about P3, P4, P2, P3, P4. कंपेयर करो और नंबर ऑफ एक्सचेंज निकालो. When you are trying to, let me add one more slide to it and I can discuss. Need to do more practice on this. So अब आप सोचिए what compare P2, P3, P4. How many exchanges? Exchanges. So ask yourself this question. You need, oops, sorry. Oh yeah. What happened? So you need to ask yourself two questions. How many exchanges are possible in each of them? How many exchanges are possible? Which one is having lower energy? energy among the three. So these are the, so you consider three different configuration P2, P3, P4, and then try to answer these two questions. You will get to understand many more things, and you will be able to. So P2 already we have discussed. There is only one exchange possible. P2 we know only one exchange is possible. That we have seen. What about P3? In case of P3, suppose we have three electrons. Now let's label them as 1, this is 2, this is 3. How many exchanges are possible? One can exchange place with 2. It can also exchange with this. And then we can also have another exchange with this. So between this and this, so you can have, these are the exchanges possible. So total 3. Number of exchanges possible 3. In P2 you have 1. So each of these exchange, during each of these exchange you have energy released. Each of these exchanges energy is lowered. By what we have denoted as pi e. Pi e per electron exchange here. So it's a 3 times. So total energy lowering is 3 times pi e. Now you can see also what we have just told you. I just told you the formula that we can apply. This one. Going by this formula, you can also think of, when we are talking about P3, n is the n here, the number of electrons with parallel spins, with the same spins, is n is equal to 3, right? The way we have considered, if we are having 3 electrons in parallel. So now switch to the formula and you will get the same answer which I have got without using any formula. Number of exchange 3, so n is 3. Use this formula, 3 into 3 minus 1 by 2 exchange. So you can see, so what you are getting finally is 3 pi e, right? So ये formula secondary है, ये main नहीं है. पहले आपको just looking at the configuration, you should be able to find out how many exchanges are possible. Forget the formula, right? So same spin and same energy, if they are in the degenerate orbitals, you can easily find such thing and then exchange them together. Exchange can happen in this manner. Okay, so, so exchange energy is the responsible to this. So that's what we have been telling all along. So now, so यहाँ पे मैंने कोई formula use नहीं किया and मैं उसी answer पे पहुंच रहा हूँ, 3 pi e, right? इसीलिए मैं कहता हूँ फार्मूला रटो नहीं, फार्मूला सेकेंडरी है. जब हमको जरूरत पड़ेगी, अगर मैं समझ रहा हूँ कॉन्सेप्ट को, मैं फार्मूला डिराइव कर लूंगा, बना लूंगा अपना. ओके, डोंट मग इट अप. don't mug up the formulas. Understand the concept first. And so this is so in case of here you had one exchange possible, it was pi e. The exchange energy was pi. Here it is 3 pi e. What about p4? Now let's consider p4. Number 2 p. So I have 1 2 3 4. 4 electrons are here. How many exchanges are possible? Number of exchanges. Again, ask yourself this question. Number of exchanges possible is how many? Again, there are 3 spins up spin and 1 down spin, right? So 3 spins of the same type. So again we have 1 and down spin has no counterpart. जो down spin वाला electron है, electron number 2 has down spin, so it cannot exchange with any other electrons. Okay, only the electrons with the same spin, can undergo such interaction, exchange interactions, right? So again the number of exchanges possible here is 3, uh, is 3, and so energy, exchange energy is 3. Wow. So P2, P3, P4. So now what you can say? Exchange energy is a negative term. Exchange energy is a negative term. Energy is lowered when such interaction happens. The energy of the system is experiences a lowering of energy. P3 has 3 exchanges possible. P4 has also 3 exchanges possible. So both have same exchange energy. P2 was having only less exchange energy, so that is the energy of that system is higher. Energy of P as compared to P2 और P3 को compare कीजिए. ध्यान दीजिए, compare. So now what we have here, follow up the thing with ध्यान दीजिएगा. So we have compare P2 versus P3. Exchange energy, this is equal to pi e, and here it is, in this particular case, here the exchange energy is 3 times pi e. So pi e is a negative term. Exchange energy released per pair of electron. जब per pair of electron, energy released per pair of electron exchange. Okay, एक पेयर का जो exchange होता है, तो उस तरह से जो, so in those terms you can always discuss and arrive at a situation. So definitely, so P3 configuration is, so this is negative term. We say that this is energy release, so this is a negative term. And if we have greater electron exchange energy, then we say that it is more stable. Energy is is lowered, so this will be more stable. So चलिए P2 और P3 को आपने कंपेयर किया, you can arrive at a conclusion that P3 is more stable. Now उसके next एक step आगे जाइए, add just one more electron, you have P4 and compare again. So you are filling the, so सोचिए you are filling the shells, filling the subshell, one electron one at a time, and P2 P3 you compared, you have seen that P3 is less stable. Now compare again P3 versus P4. What's your conclusion here? How would you account for the stability of P3 here? कैसे? Oops. कैसे करोगे भाई? बताओ. यहाँ पे, so what you have? Again compare the exchange energy. Here this is equal to 3 times pi e, and in this case also I said that they have same, because the 3 up spin or 3 or only one down spin was there, so it was always have this picture in with you. So you are talking about P3, P3 and P4. Very fundamental thing, you might not have tried to understand this thing from a very long time. Okay, so exchange energy here is also 3, same exchange energy. So we can't say on the basis of exchange energy that which one is having lower energy, but look at very carefully. In this particular case, Px, sorry, Px, Py, Pz. So in the same region of space, two electrons in a small space, you have two electrons, so repulsion will be high. Two electrons occupy same region of space around the nucleus, and so there will be greater repulsion as compared to P3, and because of that the energy of P4 will go up. P4 will be higher in energy and P3 will be less. So two electrons occupy same region of space around the nucleus. Okay, so repulsion energy, high energy. So when we compare P3 and P4, they have the same exchange energy, but in case of P4, the two electrons have to be accommodated in a small region of space around the nucleus, and so the repulsion increases, and because of that P4 has higher energy, P3 has less energy. Overall conclusion is P3 is lower when you compare with P2 or with either with P2 or P4. Next higher up, next lower. One electron less, one electron higher configuration. So this is the way you have to show why the uh, P3 is having lower energy, half fill is having lower energy. ये आपको समझ में आया? So now a question for you. In the same way, explain the D4, compare D4, D5, D6 and account for the stability of D5 configuration. why D5 will be stable. So the way I have told you about P2, P3, P4, you need to answer the same things. Account for the extra stability of half fill D subshell. Okay, so that's what you will have to do. I would so just I would like you to मैं discard कर दिया. I should have kept that. So assignment for you is that कीजिएगा आज ही कीजिएगा क्लास में बैठ के बहुत खाली समय रहता है आपका ठीक है so I'm assigning this to you account for uh, so what you are going to do is that again compare D4 D5 D6 configuration and account for the extra stability special stability of D5 ओके कर सकते हो जैसे मैंने P2 P3 P4 किया वैसे आप D4 D5 D6 भी कर सकते हैं करके देखिए अच्छा अब आपको तो ये जो फार्मूला में यहाँ पे आपने एक और चीज देखा अब पता नहीं आप लोग सवाल नहीं पूछते हो Oopsie, क्या देखा आपने ये समेशन क्यों आया किसी ने पूछा नहीं मुझसे वाई दिस समेशन कुछ बता सकते हो कोई वाई देयर इज अ साइन ऑफ समेशन हियर एनी आइडिया अभी तक तो हमने ऐसा कुछ समेशन का यूज नहीं किया बस हमने n को यूज किया जैसे p3 में n 3 था तो यहाँ पे 3 हमने डाला 3 - 1 p3 कॉन्फ़िगरेशन था 3 डाला और कर दिया समेशन का साइन क्यों है बच्चे सोचा करो सोचो 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 let's consider p6 let's consider p6 so let's start considering p6 p6 में क्या होगा एक्सचेंज एनर्जी बताइए observe Q4 six. So we have six electrons. So three electrons having upspin, so exchange is possible within them. Three electrons with downspin, again exchanges are possible amongst them. So 3 plus 3 total, there you will have 6 exchanges in total. So you have to account for the downspin and upspin electrons, and in each of these exchanges energy will be released. So we are accounting for that, right? So I said three exchanges between, ठीक है. So ये तीन exchange हो गया. Three exchange with the red ones, and you also have three exchanges amongst the other three. ब्लैक वाले जो हैं, जो डाउन स्पिन है, इनके बीच बीच एक्सचेंज होगा. इसका इसके साथ भी तो होगा, और इन दोनों के बीच भी होगा. And then you have also one exchange amongst sorry, amongst these two. So you have for upspin, three electrons with upspin, three electrons and you also have three electrons with downspin. When I say downspin, that means ms is minus half, or the z component is pointing downwards along the z minus z direction. So इसके लिए three possible exchanges, and for this also three possible exchanges. Total exchange energy three. ठीक है ना. टोटल एक्सचेंज एनर्जी 3 पाई ई प्लस अगेन. तो दोनों की वजह से आपको दो दो होगा. डू यू रियलाइज दिस? सिक्स. समझे? Now the formula says, so for such cases you have that summation. Summation is when you have exchanges possible amongst the upspin electrons. There are exchanges possible amongst the downspin electrons. So there, that's the point where you will be requiring that summation when we talk about ex. So that n into n minus 1 जो था summation by 2 for upspin, like that. So you remember this formula, na? N minus 1 into pi e plus the other one for down spin. You can write again into n minus 1. So these are for the down spin. So that's how you are having that sign of summation. So now you calculate when n is equal to 3. This is 3. So 6 plus. So this is how you get this thing. Okay. So remember this. समझ गए. सो एक्सचेंज एनर्जी को लेके अब आपको कोई कंफ्यूजन नहीं होना चाहिए. जब आपसे मैं पूछूं P6 का बता दिया तो अब आप D10 का भी निकाल सकते हैं इन टर्म्स ऑफ एक्सचेंज पर electron energy release per exchange. So pi e is the symbol, so take that as constant and then exchange, refer to the total exchange energy in those terms. So now you can, so P2, P3, P4, you can write. So everything, I think it should be clear now. How many number of exchanges are possible? So always write these things, how many exchanges are possible, because this will be very important when we go to the next few things. So so two types of interactions now you know, and now we are adding a third type of interaction, which so when we go to the spectroscopy we have to be aware of all these things, क्योंकि उतने सारे एनर्जी स्टेट्स बनेंगे, फिर उसी को आप माइक्रो स्टेट बोलेंगे. ठीक है. छोटे 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 इतने सारे, अरे छोटा छोटा कंसिडरेशन से इतना सारा एनर्जी स्टेट बन गया. थोड़ा थोड़ा एनर्जी का डिफरेंस है. पहले आप सोच रहे थे कि P2 में है तो सबका तो एनर्जी बराबर होगा. अब आपने देखा कि नहीं, इसमें तो तीन अलग अलग हो सकते हैं. ठीक है. And now we are adding a third type of interaction between, we are going to understand a third type of interaction that happens between the electrons. You know, the angular momentum, each of these electrons have angular momentum, spin angular momentum, orbital angular momentum, and these angular momenta, plural I should say, these angular momenta interact. How do they interact? Because whenever you have spinning electron, it has magnetic moment, and two magnetic moments can interact, and that magnetic moment is coming from the angular momentum, right? So spin angular momentum, orbital angular momentum, both contribute to the magnetic moment, and then there is interaction between the things. So you have to then think about those stuff, the one that we have studied. So we are moving on to a new topic, spectroscopic term symbols, and yeah. So this is what we have already learned, how the staggering of energy levels. Sorry. Hmm. So whenever you move to, whenever you talk about spectroscopy of multi-electronic systems, we cannot view the electrons, one electron in isolation. And there are, as you have just seen, there are interaction. There is Coulombic interaction on account when we visualize them as being point charges. Then there is also another interaction that we have just seen, is that exchange interaction. And the third one that we are going to discuss is through, so each of these electrons have magnetic moment because of this spin and angular momentum, and which is the origin of that magnetic properties in any system, any fundamental particle, the origin of magnetic property is the spin. Okay, spin होना जरूरी होता है, और spin, so that way two electrons will behave as tiny magnets, and just like you bring your two magnets together, you can have head to tail interaction, tail to tail interaction. So that kind of interaction will attractive, or two magnets can have attractive as well as repulsive interaction. So there are things that we have to discuss besides the splitting of energies, all these things that we have learned in, and when you have so you tend to have where is that? So this is what we have already learned, and exchange energy by. So this is what we already know. Okay, yeah. One few more things you can test yourself. This जितना प्रैक्टिस करोगे उतना अच्छा है तुम्हारे लिए, नहीं करोगे तो तुम्हारा क्या है? अब you can do, you cannot do, you should do. So as much as oxygen has 4 electrons, find the number of electrons that can be exchanged in each case and the Coulombic exchange energy of the atom. So try to do that, just practice. A nitrogen atom with 3p electrons could have 3 unpaired electrons. So compare these two configurations. So which element is lower energy, why it will be lower energy. So try to answer this. This is just for your practice. And when we are talking about absorption of light in multi-electronic system, it will be yes, as I said, you have to consider, आपको सारे एंगुलर मोमेंटम को सम करके देखना होगा, जैसे हमने कहा कि यू हैव टू व्यू इट इन टोटलिटी, यू कांट व्यू इट आइसोलेशन, दैट इस इलेक्ट्रॉन के पास इतना एंगुलर मोमेंटम है, इसके पास इतना है, नॉट लाइक दैट. So the orbital angular momentum, spin angular momentum, they interact, and then there is also interaction between angular momentum of one electron with angular momentum of other. Okay. So besides exchange interaction, besides the Coulombic interaction, you also have this third type of interaction, which basically happens on account of they behaving as a tiny magnet, and the magnetic moment arises due to that angular momentum. Okay, and so when we see there are a lot of energy states that we can create, each one of them configuration that we can have different, slightly different energy, we call them micro states. So initially you were having one state, P2 state जो आप visualize कर रहे थे, अब उसमें कई सारे 3 state बन गए. अब आप देखेंगे the third state which has we have put in the lowest energy state where the exchange energy is there, one electron exchange. Now the third state will also split into 3 energy system, 3 different energies. So you will have total of 5 microstates for these things. So only P2 considering. So that's what 5 different configuration you can have. 3 तो आपने देख लिया, अब वो तीसरा जो था उसमें फर्दर 3 हो जाएंगे स्प्लिटिंग, और इस तरह से. So that is, so a classical initial visualization is like this: spin and then orbital motion. So although this is a classical visualization of electron, I also further discussed that this picture will not be entirely correct. Spin का जो हमारा concept है as a spinning charge sphere is not entirely correct, of course, because we have seen that when you calculate the velocity, linear velocity of assuming it to be a sphere of femtometer or attometer in dimension, the linear velocity turns out to be much higher than speed of light, about 100 times higher than speed of light. And that is not just not possible. There's something wrong with the concept that we have been using. Um, anyway, but spin is a fundamental thing. It remains with all the particles. And because of that, you have intrinsic angular momentum. And when we are talking about 2, so we go back to again P2. P2 configuration you had 3 दो इंटरेक्शन आपने कंसिडर किया कोलम्बिक और एक्सचेंज इंटरेक्शन आपके पास 3 एनर्जी स्टेट आ गए अब आप फर्दर interaction between the angular momenta if you start so electron 1 and electron number 2 if both have L is equal to 1 this is the angular momentum vector what is this this is angular momentum vector so there are 3 different ways in the angular momentum vector can add up this is one of them and in this case resultant is one so when two vectors are placed aligned they're perfectly aligned you have maximum resultant value the two vectors can also be oriented so electron number 1 electron number 2 the two vectors can be slightly different way they can combine in this case the resultant is same L is equal to 1 L is equal to 1 this is also resultant L is also 1 so this vector is also same so resultant remains same and then the third the when we have P2 configuration the two electrons electron number 1 electron number 2 they can have their orientation of the two vectors angular momentum orbital angular momentum can be just opposite to each other and they might cancel out and in that case the resultant capital L turns out to be 0 we say that so just like you were having a small l so you were having when for one electron you were having L 0 1 2 you were writing s small p small d now when you are taking the sum of these two angular momenta again your possibility is 0 1 2 and now you are using capital P capital D so that's how we are writing these things so this initial visualization has to be there that angular momenta are somehow interacting one electron has orbital angular another electron has angular momentum and these vectors are somehow interacting and according to that the resultant total orbital angular momentum will be having 2-3 different cases like this and accordingly energy state will change so I think I'll continue this further tomorrow with a full-fledged discussion on term symbols meanwhile whatever I have told you just do that d4 d5 d6 discuss how d5 is more stable and don't write a one-liner Kunz rule just end of the story khatam ऐसे नहीं Kunz rule has got a it is a well thought out thing which has explanation thorough explanation why it follows happens like that and you have to follow that path where a complete explanation without using the word Hunds you can actually explain everything okay so please do that I'll take it so this